Hi everyone and welcome back to the multiverse of 100 plus data science project series. And in this video, we're going to building here these car parking detections without the space counter using deep learning. And this is the web application that you can see in the screen. Parking space detections using deep learning is not actually here. And you can see free spaces right now 5 and 1, 2, 3, 4, 5. And occupied spaces is nothing but the 51. You can also count on here. And these applications you're going to building from the Askers using Python and deep learning. So let's go on here. For building these applications, we're going to using here the Jupyter Notebook and the BS Code. So you can using the PyCharm or Google Colab itself here for building the deep learning model. So let's go on the Jupyter Notebook and try to start the coding part right now. First thing first, I'm going to importing here all of the important library, and after that, I'm going to load the dataset from my directory. So let's first importing here NumPy. Let's say import NumPy as NP. Then I'm going to importing here the OS, also called the operating system. And using this OS, we can create the list of the images and we can simply load it from my directory. Then from Keras, I'm going to importing here the applications. So let's say import applications. So which are having the applications regarding the TensorFlow Keras. Then I'm going to importing here the image data generator. So which actually help us to do the data augmentation. So let's say from Keras dot processing dot image, I'm going to importing here the image data generator. That's called image data generator, right? Using this one, you can do the data augmentation if you have the less number of data. We are also going to use this one for creating the more images using this image data generator. Then also I'm going to import it. Let's say from Keras, I'm going to importing here the optimizer. So optimizers, right? Then I'm going to importing here my sequentials as well as my model. So let's say from keras dot models, I am going to importing here the sequential. Let's say sequential as well as the model. See one thing, if you are using here the latest version of TensorFlow, you can adding here the TensorFlow before the Keras. Let's say TensorFlow.keras. I'm going to importing here the applications. Then TensorFlow.keras.preprocessing.images. We importing here the image data generator, and same thing for here as well, right? Then what I can do? Then I'm going to importing here from TensorFlow.keras dot layers. I am going to importing here the dropout. Then I have my flatten actually help us to make our vector or a multi matrix vector into one single vector. I mean the multi-dimensional vector to the single line vector. Then we have the dance. Using this one, you can add it to the last layer as well. Then you're going to using here the global average flowing. You can also using here the tab key from your keyboard for getting the auto suggestions. So yeah, it will working. I tap it. Let's say average. Then you have the pooling. Okay, P should be capital. Pooling 2D. You can see here right now it is working. When you press the tab, it will take 2 or 5 seconds. Then it will give you the auto suggestions right in your Jupyter notebook. So shift enter. Otherwise, you can also using this one. Now you can see here it running this shell right now. Now what you can do is simply going to load our training and the testing file. So let's say load. Okay, we have the load, train, and test file, right? Okay, so let's go on the markdown and shift enter. Now what I can do now, so we have two folder. One is called the train and another is called the test. So what I can do is simply going to first take in the current directory where you are going to working on. So let's say os.get cwd. So which will help us to give us the current working directory. Then we can specify the folder. So the folder is available inside my, if I go beyond my folder, then you can see this having a folder called train data. Now inside this train data, I have my train and the test folder. So what I can do, I can go inside my train data, right? Then what I can do, I can go on my folder as well. You can see here in my train data, I have my test and the training folder as well. So I can giving here the path of that. So let's give it, let's say train, right? So it my training folder data. Now we're simply going to load the images from here. So what I can do, we can iterate to all the images from this folder, and we can simply going to read it and try to calculate the each of the images. So for that, what I can do, we can using here for in os dot list dir. I mean, simply going to creating here a list of directory inside my folder. I mean, if it's mean, if I go in my folder, you can see it have two folder called train and the test. And if I go inside this train folder, you have another two folder called the empty and the occupied. If I go inside this occupied, it having all of the images having the card. And same thing for the empty, it having some empty field. Okay. So what it will do, it will first checking for the current directory. It's checking for the first current directory, and after that it will go and checking all of the subfolder. So let's making it as a subfolder. So let's a subfolder in os.listdir, and we're simply going to give here my folder. So let's make it sub underscore folder. Now we have all of the folder name. Now we have the all of folder name. So what I can do is simply going to go inside this folder and using here os.walk, and after that is simply going to join with my actual absolute path. Let's say path dot join, and inside that what I can do, I can giving here two things. One is my folder and another one is nothing but my subfolder. So let's say sub underscore folder. Simple. Again, see, we simply going to go on my folder directory, and after that we simply going to iterate to by a subfolder, and then we simply go to the folder using the os.walk and joining this absolute path with the folder and the subfolder, right? Then what I can do, we go to the folder. Now we need to go to the next iteration, so that we can get here the images inside the last folder. I mean inside the occupied or the inside the empty folder. So what I can do, we can using here the next method. So next method, right? So here you go. Then this next method, I mean this line give me three things. One is the path, one is nothing but my path, another one is my directory, and another one is nothing but my files, right? So path, directories, and the files, it will give me these words. Now what I can do is simply going to creating here one variable. Let's call files of train. Let's making it 0. Okay, and we're simply going to join all of them. Let's say files train. Okay, train. Then after that we're simply going to join it with the length of my files. It will give me that how many files are available inside my files train. I mean inside my training folder. Now let's try to do the same thing for the testing as well. So let's paste it here, and then I need to make it as a test, and inside that instead of the files train, let's making it validations. Okay, and simply going to copy this out, and I'm gonna creating here another variable called files validations. You can make it as a test, but let's take it validations because we need to also do the validations when you are creating here our models. I mean fitting with our model. So let's try to printing it out. So let's try to print here the files train and as well as the files validations. Let's say validations. Then you can see it having 432 images files inside my train folder and 164 images inside my test folder. Inside this test folder, it having two folder also. One is empty and another one is called the occupied. It's mean we have the two classes, empty and the occupied, right? I mean having the current or not. Now let's try to set some key parameter. So let's set key parameters. Okay, so let's go on the markdown. So why this sets a key parameter is nothing but the constant parameter. You can simply going to changing this out. So let's giving here some constant image width and the image height. So let's say width and the image height, and after that let's make it 40, 40. That's mean we're simply going to convert our images into 48 by 40. Why? There should be some images having some different kind of width and different kind of height. So we have to making in a same width and height so that we can fit it inside our convolutional neural network. Right? Now we need to giving here my validations. I mean training path. So let's say train data dir is nothing but my training directory. So let's say train underscore data. Then we have my train directory. Same thing for validation data directory. So let's say validation data dir is nothing but my, let's say train data. Then we have our inside my test. Cool. Then you can also giving here number of sample. That's the number of train sample. So train sample is nothing but my files of train. Okay, files of train. That's mean the length of my file stream. The same thing for the validation sample. That's the number of validation sample is equal to files of underscore validations. It's nothing but the length of my validation folder. I mean, it's my test folder as well. Now you need to giving here the batch size. So let's say batch underscore size. Let's making it 32 batch. And after that, we have the epochs. Epochs. Let's making it right now tens. Okay, you can also changing this out. And then you have the number of classes. So we have the two classes. Number of classes should be 2. That's mean this is a binary classifications, right? Now what I can do now, we simply go into building our model on the top of the BGG, pretend BGG, right? I mean, we're going to using the transfer learning for creating our models. So let's making this epoch should be 50 because I already tried this out. So let's say build model on top of a pre-trained BGG. Okay, BGG. You can using here the BGG 16 or BGG 19, whatever you can use that. Okay. So now what I can do, I am simply going to using here. Let's say model equal to applications, because I have my applications already. I loaded here this library. So then I'm going to using here BGG 16. You can using here the BGG 19 as well. So it's your homework to apply the BGG 19 as well here. You can use any of them. You can using the mobile net. So let's giving the weights. So weights is coming from the image net. Okay, it's nothing but a competitions. Here all of the developer working on that. Then after that I can giving here include top. So include top is nothing but my top of the layers. So I am going to making it false because this BGC 16 is already trained on 1000 classes. And after that I can giving here my input shape. Let's making it input shape. So let's input shape. Input shape is equal to image width and as well as the image height that actually set in our key parameter and number of channels, and number of channel is 3. That's been RGB images. Cool. Now our model is ready. Now what I can do, we're simply going to taking here the last. Okay, image width is not defined. I think image width wi, why is not okay. I forget to running this out. That's why it's giving me this error, right? Now it is gone. Okay, so we can checking here on a model summary as well, but let's taking some shell as well. Let's say model dot summary, right? Then you can see here we have the summary of our model. Now if I try to checking here the layers of my model, so let's say layers, then you can see how many layer it have. You can see here this is 1 2, it have it again 2, then it having the 3, then it having the 3, it having the 3 convolution layer. So what I can do, we can simply go to freezing here top 5 layer. I mean, we simply going to taking this one layer, and with the those 2 just taking the 5 layer from here. I mean, I am not going to actually training this out, so I can freezing this out. So how can you freeze that? So let's say for layers, layer in model dot layers. So we can go to the last 10 layers. We're simply going to freeze them. 10 means 5. Why? If I'm checking this out, you can see it having 1 2 3 4 5 6 7, and with having one input layer, max pooling layer. If you're simply going to join them, it should be the 10. So we're simply going to freeze the 5 layer, which I am not going to interested to taking as a trainables. So let's making it false. Let's say layers dot trainable equal to false, because this model is already trained on 1000 classes. So I can simply freezing this out and try to changing the layer of that. Now I am simply going to creating here one functional API. So let's say x equal to model dot output first. So let's say output, and after that I simply going to simply going to pass it inside my flatten layer in a single vector, and I can give it here the functional things. Where we are not going to using here the sequential. Yeah, I actually importing here the sequentials. You can see importing the sequentials, but I'm not going to using it here. Okay, I'm going to using here the functional one, right? Now let's say let's using here the dance layer, the final layer. number of classes. Number of classes is nothing but the 2. So let's say classes. And after that, I can give in here my activations is nothing but equal to softmax, because this is the binary classifications, right? That's the softmax. And after that, I can give in here my x. And this is my predictions. So let's make it predictions, right? So now let's try to build our model. So what I can do, we can, let's say model, let's making it final, model underscore final equal to, we can using here the model. And inside this model, I'm going to giving here my inputs. And my inputs is nothing but my model dot input, which one is coming from the BGG. Then after that, I can give it here the outputs is equal to my predictions. I mean my these predictions, right? Now, before fitting with our data, we need to also compile our model, right? So what I can do, we can using here model, model underscore final equal to dot compile, and compile. And inside that, I can giving him a loss. So let's give him loss is categorical cross entropy. You can giving here the binary as well, but it's right now in the category format. So cross entropy. Then after that, I can giving here my optimizer. So optimizer is equal to optimizers dot sgd, stochastic gradient descent. And you need to giving here the learning rate. Let's give it here 0.001. And then I can giving here my momentum. Let's give it here momentum is equal to, let's giving here the 0.9 as a momentum. So let's 0.9, right? Then after that, what I can do, we can giving here my matrix. So let's give the matrix as well. Matrix. So let's give it here the accuracy matrix. I have to give it inside third bracket. So let's say accuracy. Fine. So now let's give one space, and now it's local. Okay, space. Fine. Now our model compilation should be done. So shift enter. Now you can see it's running. Now what I can do now, we can simply go into training it out. But before that, we can using here the data augmentation as well, because we have the less number of data, just having 432 and 164 instead of test data. So you can also do the image data generator. I mean, do the data augmentations. So let's do the data augmentation, augmentation. Let's try to do that for increasing our data. So let's go on the markdown, and now it's gone. Now what I can do, we can using here the image data generator, and inside that I can giving here the first rescale. Rescale is nothing but the normalize our data. So let's try to rescale it with 255. So 255 is nothing but the maximum pixel value for the images, right? So let's say horizontal images. If you know the computational very well, then you can understand it one. And horizontal flip, let's making it true, and let's making the fill mode is should be the, let's making it nearest. Okay, then after that, we can giving here my zoom range, I mean zoom in or the zoom out. Let's giving the 10% on that. Then after that, let's giving here the width shift range. Let's give it here 0.1. So let's give it here one space so that it's low code right now. Then after that, let's giving here the height shift range. Let's say 0.1. It is the auto suggestions. So I need to grab the tab key from the keyboard. It will give me the auto suggestions like that. So let's say rotation range is nothing but 5. So that's nothing but my train data gen. So what I can do, I can give it here, let's say train data gen like that. I mean train data generator. So let's try to copy this out, and I'm gonna paste it here. Same thing for the test data generator. So let's make it test data gen. Cool. Now what I can do, we need to take our data from our directory, right? Take our data from our directory. So what I can do, we can using here this train data zen, right? Dot flow from the directory. You can see flow from data frame as well as the directory. So let's give it here, and then inside that, I need to giving here my train data underscore dir. So what is this one? If I go up, you can see we already initialized in our key parameters train data dir and the validation data dir, I mean task data dir. So what I can do is simply going to give it here my train data dir. Then after that, I'm giving here my target size. So target size is nothing but my image height that you already initialize here, image height, and as well as my image width. Let's say DTH measured, right? Then after that, what I can do is simply going to giving here my batch size. So let's say batch size. So batch size is nothing but the 32, and I already initialized it inside my key parameter. If you see that, because the batch size is right now 32. I mean, each of the batches is just try to loading here 32 images. And after that, I can give here the class mode. So let's give it the class mode equal to, let's give it here the categorical. Now let's try to copy this out, and it will be the same thing for the validation data then as well. So let's try to copy this out first, then going to put it inside the same folder, and this is the called the train generator. Okay, now it should be my test data then. So let's say test data gen dot flow from directory. It should be my validations data dir. So validations data dir, and target size and image height and width should be same. So it should be my validation generator. Let's say validations generator. Cool. Okay, that's already you can see here found 432 images belonging to class and 164 images belonging in to class. Now what I can do now is simply going to fit our models. So let's fit it. That's the model underscore final dot fit, and inside that it should be the fit generator, not fit, because we're using here the image data generator. So let's first pass here our train data gen or generator. Then after that, inside my step per epochs, okay, let's say steps per epochs, we're simply going to give it here number of train sample divided by batch size. Again, step per epoch should be number of the train sample divided by batch size. Then we have the validation step, and validation step should be my number of validation sample divided by batch size. Same thing here. For the step per epoch is nothing but the number of train sample by batch size, and validation step should be number of validation step sample divided by batch size. Now I'm not giving here epochs, so let's give here the epochs. So using here the epochs, same things. If you can see, I already give it here epochs equal to 15 epochs, and then the final one is called the validation data. It should be marked validations data generator. Validation generator. So now I'm going to shift enter, and now you can see our epochs is started. Okay, you can see epochs is started. Okay, so it will, I hope so, it will work fine as well, and it will ending soon. So I'll back after and the epoch is done. Well, so now you can see here our training is completed, and you can see here I got here 98% accuracy and as well as 94% accuracy on the validation data. Now what I can do, I am simply going to do one plotting so that I can see my accuracy as well as the loss in a plot. So for that I can import in here matplotlib. So let's import matplotlib.pyplot as plt. Then after that I am simply going to plot it. Let's say plt.plot. And then what we have one we need to have one history objects, but unfortunately actually forget to give it out. So I need to give it again and try to train my model again. Let's say history is equal to model underscore final. This one same things, but I forget to give here the history. If you're doing this mistake, so you need to train up your model again, right? So now let's try to train our model again, and I need to wait for agains. Okay, but better I'm going to writing here my codes. Okay, so for that what I can do, we can use a history. So in our history, it having two things. It's nothing but one accuracy, and another one is nothing but called the validation accuracy. Okay, so it's better I can actually record it when it is done, because the training is actually running and also this recording. So that's why I think so. I need to start later on. Well, so I'm back again, and now after training it's again, and we got here 99% accuracy, and the validation accuracy is nothing but 93%. So now what I can do, I am simply going to plot it right now. But don't do this kind of mistake if you're running this application for the first time. Make it you give it to the history as well. Save it the history if you wanted to plot it out, right? So now what I can do, I'm simply going to plot it. So inside that I can give in here my history. So let's say his story dot history, right? And inside this history, we have my accuracy. So let's say accuracy. Then after that, we have my validation accuracy as well. So let's try to pass it here. Let's try to take one shell before that you can see what actually happening here and what I'm talking about history. So if you see the history, and if I go inside my history again, history, then you can see here inside my history, I have my loss, I have my accuracy, I have my validation loss, as well as the validation accuracy. So what I'm going to do, I'm simply going to taking all of the validation accuracy and the accuracy in a list and try to plot it out, right? So I'm taking here from the accuracy from my list and as well as my validation accuracy. There should be the validations accuracy. Now I can giving here one title. So let's say plt dot title, and inside that I can giving here my model accuracy. Let's say model accuracy. Fine. And after that I can giving here on labels. So let's say plt dot y label is equal to my accuracy. Then inside that x label I need to have my epoch. So let's say plt dot x label is nothing but my epochs. So epochs. Fine. It should be the epochs. And inside my legend, so plt dot legend, I can giving here my trend and as well as my test. So let's give it here test. And after that I can giving here my locations. So let's say lock equal to, let's say, giving here the upper left. So upper left. Then after that I can simply going to show it out. Let's say plt dot show, right? Then you can see just to white, and you can see how the model accuracy is look like. Okay. You can see here how it will look like the model accuracy. Okay, and you can see it's quite good, not so bad, because I run it again, so that's why. But yeah, that's really fun. Okay, this is how you can actually showing up your model accuracy. I'll add one picture as well in this side, of how I actually training it out before, then how the graphics look like. Now it's look quite awkward because I trained it the second time, that's why. So yeah, just for ensuring that how can you plot it out. Let's make it loss and the validation loss. So it should be my validation loss, and there should be the model loss. Okay, loss, and this should be the loss, and all of the things are same, just except this. Yeah, it should be uploaded because it's not in a subplots. So this is how the loss look like, okay, validation loss and the model loss. Okay, because I trained it again, so that's why this kind of thing happening. It will starting from the rest of them, that's why. Okay, now what I can do is simply going to creating here one predictive system. But before that, let's try to save our model. That's the model, and let's go final and save. And after that, we can give it here my model underscore final dot h5. If you're running these applications, I mean, if you're running this epochs, first time your graph is not look like that. Your graph is not look like that, and we see that it don't have any too much gap because this graph is quite low. I mean, quite low, the image of this size of the figure, so that's why it's looking like that. But if you're actually running this for the first time, the graph is look like that. The graph is look like that. It is starting from the zero, but right now you can see starting from 93%, right? Just for showing this purpose, actually plotting this out, right? Okay, then what I can do now, then after that I can simply going to give here one class dictionary. So let's say dictionary. So in this class dictionary is nothing but an empty, and inside that I can simply going to give it here my two classes. So one is nothing but called car, and another is called the no car. So let's making it first empty and the occupied, or empty means no car, you can say like that, no car. And then the second one is nothing but the car. Second one is nothing but my car. Okay, so here I go. Then what I can do now, then simply going to give it to the first index, should be the no car, and second one should be the car. Okay, just getting our map. So if I try to printing this class dictionary, okay, class dictionary is not showing up. You can see here 0 equals to no car and 1 is nothing but the car, right? Cool. Now what I can do is simply going to creating here one predictive system, system, right? and Markdown. Cool. Now let's try to creating here one predictive system using OpenCV. So let's first importing here the CB2 so that we can load the images from our directory. That's I'm going to importing here the numpy as np. So let's say numpy as np. Then I'm going to creating here a functions called the make predictions. So let's say make prediction, and after that I can giving here my images, right? Then I'm simply going to load it. Let's say cb2.imread, and inside it I can passing here my images. Now we load the images, right? We need to also resize our images so that we can pass it inside my model. So it should be the image, and after that I can using here, let's say cb2.resize, and I can passing here my images, and I need to giving here my path of that. Let's say, sorry, 48 cos 48 is nothing but my image height and the image weight. So it should be in the same thing. Let's call image. Now our image resize is done. Then we need to also do the normalization of our data. I mean, rescan our data so that we can divide it with the higher pixels. So our higher pixel is nothing but 255. So let's divide it with the 255, and let's making it as an image as well. So let's say image equal to image by 255. Then after that, I'm simply going to convert to the 4D tensors. So let's say np.expand dimension. So expand dimensions. So what is actually expand dimension actually? See, expand dimension is nothing but the 4D tensor. That's mean the reshaping. So how can we reshaping one data so that we can pass it inside the CNN? So the reshaping thing like that, you have the number of images, how many images should be coming up here, then your image height, the image width, and number of channel. So this is called the 4D tensor. This is called the 4D tensor. Okay, you need to pass it inside your CNN models. One is number of images. I mean, how many images should be coming up here. For predictive system, it having the one images, and this np.expand dimension actually help us to create our data in the vectors in the form of the 4D. So let's say image and axis is equal to nothing but the 0. Okay, it should be the, let's making it image, and then I'm going to making it image as well. Now what I can do, we're simply going to predict it. So let's try to predict it. So let's say class predicted is equal to model underscore final final dot predict, and inside it I can passing here an image. Now let's try to taking the maximum of that. So it should be give me one integers. So let's say int id and np dot arg max, and after that I can give in here my class predicted, and after that I can give in my 0 index so that we can give it the first ones, right? Then level should be my class dictionary that we created for car and the no car. Let's giving here my int id, and finally we're simply going to return here our levels. Okay, so now we need to giving here on images inside my class predictions. So let's go on the folder, and then taking one images. So let's take one images. Let's take one images from occupied, I mean my car. So let's copy this one, and after that I am simply going to paste it at the out of the folders, right? This is roi underscore 1.png. So let's give it here path of that. So let's roi underscore 1.png, and then you can see dict object is not callable. Anything error? Anything error? Class dictionary equal to 1. Why this error? Anything error? So it should be the roi underscore 1.png, right? So make predictions, predict equal to images, and then after that let's go on here and check that out. Predict equal to class predict equal to 1, and class dictionary is not callable. But why? It's coming up from here. Model final dot predict is image, right? This image is coming up here. Image, we divide it, we pass it, but why this error? Again, check this out. Dict object is not callable. Let's try to remove this one and try to taking these ones and see same error we got or not. We got here 1, right? We got here 1. Now once means it's nothing but the card. Yeah, it's having the card. So let's try to check that. Okay, it's not be callable because it's a dictionary, so we need to give it inside on the third brackets. So that's all. Now you can see it having a card, right? It's having a card. Now let's check another one. Go on here and try to go on the test now, and go on the empty. Let's check into one and copy this out, and let's try to pass it here. And this call is spot 169.jpg. 169.jpg. So let's try to go on here, make prediction, and after that I can give in here this one dot png, sorry, jpg. It should be no car, right? It's really working very fine. Now let's try to save our model. Let's say model underscore final is we can save it out, and then we can give it here a model underscore final dot h5. Cool. Shift enter, and our model is saved, and you can see model underscore final dot h5. Cool, right? Now what I can do now, we're simply going to now creating here one parking plot. Okay, I mean plot, so that we can testing it out that if the car is available in the parking plot or not. So for this case, we're going to using here the OpenCV ROI, so that we can create a rectangle, and after that we can cutting this out, and we can testing it in the specific area that it have in the car or not, right? Now let's try to checking this one. How can you do that? And as well as I'll show you that how can I collect this data. How can I collect this data from the parking plot, right? So let's go on the VS Code right now and try to do the coding part here. So right now we are in a VS Code. So now what I can do, we're simply going to creating here our parking plot positions, as well as we are going to see that how can you collect the data that we use in our CNN model, I mean creating the models. So now what I can do, I am simply going to creating here an empty Python file. Let's say data collection .py. So here I'm going to do the data collections as well as the positions of the frames, I mean my parking plot. So if you see that in our sections, in the section you have two files. One is mp4 file. This is nothing but my testing file. Here we do the testing one, and we're simply going to convert this, I mean taking one snapshot of that, and we have one png file of that. It's nothing but my parking plot, the car or the parking plot in a png format, image format. Now what I can do, I am simply going to import it. Let's say first importing in the cb2, because using cb2 we can load the images. Then after that what I can do, I can using here cb2.imread, and inside that I need to giving here my path of my images. So let's say car1.png. Then I need to showing this out. So what I can do, I can using here cb2.imshow, and inside that I need to giving here one window name. Let's give it here image, and after that I can giving here the image. So I need to also put it inside a variable so that I can show this out. So let's pass it here, and after that what I'm going to do, I'm simply going to giving here one wait key. So let's say cb2.wait key, and after that I can giving here 0, right? Then what I can do, I am simply going to run in this one. So let's try to running these ones, and then you can see here our images, how the image look like. But here the problem that our image is not fully visible. That you can see if I open these images, and you can see here this is the full images, but this full image is not visible. So what we need to do, we need to simply go to resize these images. So we can resize this one. So let's say image equal to cb2.resize, and inside that I can pass in my image, and also giving here the width and the height. So let's give it here 1280 and 720, and try to running this out right now. Now you can see our image is visible, and how the parking plot is look like. And now what I can do, I need to creating here on rectangles in the each of the parking plot, how the car is situated. So I need to just detect this one. So if you are to creating on rectangles, so what you can do, you can use the cb2 as well. So let's try to creating one rectangle of that. So what I can do, I am simply going to create a rectangles. So let's say cb2.rectangle, and inside that I need to pass in my image, and after that I need to give me the coordinate. Coordinate should be x1 x2 and y1 y2. That's nothing but the height and the weight of our rectangle, and higher it will start it. So I can give in here one number, let's say 85160, because I already hit and trial of that. And after that, what I can do, I need to giving here my y1 and the y2 as well. So what I can do, I can giving here 215 and 225, and then I need to giving here one color. Let's giving here 255 comma 0 comma 255. Okay, then after that I can giving here my thickness of my rectangles. Now if I try to running these applications, I mean script, then you can see here one rectangle is created. One rectangle is created, which one having the height and which one having the width. Now we simply going to cutting this out. We simply going to cropping this out and try to passing these images inside our CNN model. I mean our deep learning model, or you can say transfer learning models. We can simply going to passing this out. That's mean we need to select one rectangle. We need to select one rectangle from each of the parking plot and try to check that is there having any curve or not. That's simply going to calculate them how many free spaces here. But now you can see we just simply going to randomly, I mean manually creating this one. If you click on here, it will automatically create a rectangle and try to saving these images in a specific folder, because we also know that how can you collect the data as well, right? Now what I can do, we simply going to using here one callback functions, so which actually help us to doing these ones. So now what I can do, we're simply going to creating one callback. So let's say cb2 dot mouse callback. So let's call the mouse callback, and inside that I need to giving here the same window name. So window is nothing but my this image, same window name, but it not be here. You need to give it inside after the frame so that it will showing these ones, and then it will give here one method. So let's say mouse click, like that. So now you need to define this mouse click method here. So let's say def mouse click, and also you need to pass your images, these images inside inside of the while loop. Okay, so let's try to first making it pass right now. Okay, now let's creating here on while loop so that the frame is updated automatically. So let's say while true, and after that what I can do, I am simply going to put it inside here, and as well as these images. Let's cut it down, and I'm going to pass it here. And then what I can do, we're simply going to make it small. Cool. Now what we have on callback methods, and now let's try to making it. Let's say k equal to cb2.white key equal to 1, and if k equal to over d of the q, I mean anyone press the q from the keyboard, it will automatically gone. So let's try to break it. Okay, now let's try to save it and try to run it out and check that. Yeah, if I press q from the keyboard, it will automatically gone. Cool. Now let's try to implement this mouse click event, right? So what I can do, we simply going to creating here on rectangle, right? So the rectangle size is nothing but, you can see the constant size. It's nothing but a constant size right now, right? Now let's try to implement this mouse click. Then we're simply going to jump on that. This is going to changing this rectangle one. I mean, when the user click, then it will automatically get in the positions of that and try to creating the rectangle on that. So now what I can do, this mouse click taking first one events. So events is nothing but the mouse click event, or the left button or the right button, whatever it is called the events. Then we have the X and the Y positions. Then you have the flags, and as well as the params that you can pass it here. Now what you can do, first you're going to check in that if the events is equal to cb2 dot event okay, event left button down. I mean, if anyone pressing the left button from the mouse, it will creating the rectangle. It will creating the rectangle, and as well as we can show this position data inside our rectangle data as well. समझ आया आपको? I mean, how the user clicking the left button from the mouse, it will taking all of the positions, and this position should be go to the inside my while loop and creating one rectangle on that. Okay, now what I can do is simply going to having one position list. So let's say position list is equal to dot append, and inside that I can append here my position of the X and Y. Now I have to creating here this position list. So this position list is nothing but one empty list. Cool. Now inside this position list, I have all of my X and Y. Now I can simply going to iterate to all of the value from here. Let's say post in position list. Okay, then after that, based on the x and y coordinate, I can creating in the rectangle. So let's creating here one width and the height. So let's say width is nothing but 215 minus 85. It should be 215 minus 80, it should be 130. And height is nothing but 225 minus 160, so it should be the 65. Okay, now we can using this one here. You can using this one. So let's making the positions, and the y-axis should be the positions. So it should be positions of the 0th index plus width, and positions of the first index should be the height. Cool, same thing. Now if I'm trying to save it and try to run in this script, and if I click here, and then you can see it's getting one rectangle. You can see it's getting one rectangle. See how cool, right? It's creating the rectangle, right? Now if I try to press the Q and try to run it again, and then you can see here it gone. This rectangle is gone. That's going to save this out, right? One more thing. If I try to press, you can see if I give here one rectangle on here, but I can't remove it. Unfortunately, it can be happen in the human error. I can giving here one wrong rectangle here, but I can't removing this one. I can't remove this. But how can I remove that? Yeah, I can remove this another one. Let's say if the events, is equal to let's say right button. It's equal to the right button. Let's say cv2 dot event the right button down. Then what I can do is simply going to taking all of them. So let's say for I and the positions in enumerate, I simply going to enumerate here our position list. So position list, then what I can do is simply going to remove it. Now how can I remove that? Let's say if I run in this one, and let's say I'm creating one rectangle on here. Now let's say I'm simply going to removing this one. So if I clicking this right button from here, this position of the click should be the near to the rectangle. If it is near to the rectangle, then it will deleting this one. Now how can you do that? So in your positions, it having the x, y, and the y1. I mean x coordinate and the y coordinate. So let's take it from the positions. Now we also having the index number as well. Now we can check that if the x1 is plus equal to x and get equal to x1, that's mean the inside our width. That's mean this is inside our x coordinate, and y1 is y. Then y1 plus height. If it is between them, we're simply going to pop it out from our list. So let's say position list dot pop. So it will popping the index number, the same index. Now if I try to save this out and try to run in this application again, I mean script again, then if I giving here one thing and let's say wrong thing here, then if I using the right button, and you can see it gone. Cool. But here also one problem that it not saved. I mean, when I run in this application again, the rectangle should be same as it is. So you can save it inside a pickle format. So let's say import here the pickle, right? And after that I can dump it out. So let's say with open, and inside that I can giving here, let's say car position dot pickle, and we can giving here the mode, let's say write mode as file. Then after that we can save it out. Let's say pickle dot dump, and inside that I can giving here my position list, this position list, and also my file name. Now I can also load it out. So let's try to copy this out, and before that I can pass it here. Okay, I can simply going to loading this out. So it should be the RB, and I am simply going to loading this out. Let's say load. Okay, I'm simply going to loading this out, right? Now we don't need to giving it out, and we just need to give it here. It's called the position list. Okay, position list. Okay, we can simply go to load it out. But if you are running this first time, your list should be empty. So you can also give it inside a try and accept block, the catch block, whatever you can say. So let's give it here the accept block. So let's say accept, and then inside that you can pass your position list as well. You can pass your position list, right? Now if I save it and try to run it here, and inside the section you can see one file is created, and you can see you can create here, the create here. See how it will cool, how cool it will create it. Now if I press the Q and if I run it again, then you can see the rectangle is as it is same. You can see the rectangle is as it is same. You can see rectangle is as it is same, right? But here is the problem. Here is a problem that yeah, it's working fine, but problem is it's not saving the data. It's not saving the data. I mean the image is cropped. It's not saved it in a folder. So what I can do, we can also saving this out. We can also saving this out. So let's try to saving this out. So what I can do, let's creating here one save directory variable. So let's say save dir equal to here you can save our images. Let's say cropped image, and here you're going to store it. So let's say if not os.path.exist. Okay, so let's importing here the OS as well. So let's say import the OS, and after that I can say that let's say exists, and then we can giving here my safe directory. It's not exit, so let's get it. Let's say os.make directories, and inside that get giving her our save directory. Cool. Now let's try to creating here a functions, so which can actually help us to save our cropped images. So let's say cropped image, and inside that you can giving here image and the positions and the index number, right? So let's try to first crop it down. So what you can do, you can crop it based on the positions. So let's get the positions from the 1 to positions of 1 plus height, and then from here to here, from the positions of the 0 to the positions of the 0 plus width. I mean width, it should be the width. Okay, so this is how we can crop our images. Now let's save it inside a variable called, let's say, cropped underscore image. Now we're simply going to join it. Let's say os.path, not path, it should be the path dot join, and inside that I can pass in here my save directory, and inside that I can give in here one file name. So let's keep it inside f string. Let's call ROI. Okay, then reason name interest, and give into the index, and I am simply going to make it PNG, right? Let's making it a save path, so it should be the save underscore path, and then I'm simply going to write it out. Let's say cb2.iamWrite. Okay, I am right, simply going to writing it out, and save path, and as well as a cropped image. Okay, then I can simply going to print in here when a statement is yes, image is saved. So I can give it here a string, a string. Let's say save cropped image. Okay, and you can give in here your save path. So let's say save path, which path it is saved, right? Now I have to use this one save crop method inside this one. How I'm creating the left button, it will storing all of the images. Now what I can do, I can giving here the cb2 dot resize. Why resize? Actually, see, if you're giving this full images just as it is images, let's see, if you're giving as it is same images, let's say cb2.iamRead, iamRead, then you have the car1.png, and after that I need to giving here the x and y. Let's say x1 y. Then if I giving here my length of my position list, so what will happen? See one thing, if I try to run in this one again, and then just to white, yeah, let's try to click on here. See, this image should be saved inside my craft image folder, but here the problem, you can see here it's not detecting the car, it's not cutting in the right positions. But why? See, how are you passing these images in a in our mouse click event, we're also going to resize it. So that's why I need to also resizing this one. So let's say cb2 dot resize. re resize resize, and inside that I need to giving here my resize height and width. So let's say this one's. Now it will working fine. Okay, now it will working fine. Now if I'm trying to save it and try to running this one and try to cutting this one, now you can see if I selecting this one, selecting this one, selecting this one, this one, this one, this one, this one, right? See how it will look like. Okay, so you need to do all of the things, all of the card from here. Now you can see here all of the images should be saved in a correct format. You can see the correct format. Correct format. It will save that. Now what you need to do when your selections, I mean carking plot detection is completed, then you can simply go into taking all the images and you can go inside the strain data folder and you can pass it the occupied. Inside this occupied you can pass here all the images which one have in the card and which one don't having in the card. You can actually simply going to put it inside the empty folder. Now cool, cool. Now what I can do is simply going to join all of them and try to check them that our machine learning model is working very fine or not. So let's try to do this out. Well, so right now what I can do is simply going to joining here our deep learning model and as well as our parking method. I mean that we implement it here, right? Now what I can do is simply going to creating here a new file that's called test.py. And then I'm going to importing here the CB2. Then after that, I'm going to importing here the pickle so that I can load here our car parking positions. And also I'm going to importing here the numpy. So let's say import numpy as np. Then also I'm going to import from keras, let's say from tensorflow.keras and .models. I'm going to import here the load model. So let's load underscore model so that I can load here my deep learning model as well, right? Now what I can do, I'm simply going to load here my model. So let's say load model, and inside that I can giving here my path of a model file. So I have a model, let's call the model underscore final.as file. So I can give it here, let's say model underscore final.as file. Cool. Now let's taking it inside the model. Well, now also creating here a dictionary for that. Let's say class dictionary. So let's say class underscore dictionary. Dictionary is equal to let's say for the 0 we're simply going to making it as a car. So let's say 0 equal to sorry no car, and if it is 1 then we're simply going to making it as a car, right? So 1 and car, just creating a dictionary that we created in our Jupyter notebook file as well, right? Now we're simply going to creating here one video capture object. So let's say cv2.video capture, and inside this video capture we are going to giving here our testing file. So it should be the car underscore test. So car underscore test dot mp4 file. Now let's assign into a variable called video. Okay, then after that what I can do, we're simply going to loading here our position file. So let's say with open, and inside that I can giving here my car positions. So it's nothing but the positions of the each of the car parking, I mean by car parking that we actually created here. So position dot pickle file. Then after that I have to giving here a mode. So let's give it here the read mode as f. Then after that I can simply going to load in here our pickle file. So let's say pickle dot load, and inside that I can giving here my file name. So that's my file. So this is nothing but my position list. Let's say position list that we created here earlier, right? Now we have our video capture objects. I mean our video is also loaded. Then we have also our class directory, I mean dictionary, I mean 0 for the no card and 1 for the card, as well as we load the model. So now let's creating here one while true loop. So let's say while true, and inside that what I can do, we're simply going to creating here one frame. So let's say image equal to cb2, not cb2 actually, video.read. I mean the video actually loading here, we're simply going to loading this out, and after that I can showing this out using cb2.imshow. And inside that what I can do, I can giving here one frame name. Let's give it here the image, and after that I can passing here my image, and then I have to giving here one wet key. So let's say cb2.wet key, and inside this I need to giving here 1. Okay, infinite time. The frame should be in infinite time. Now after that I need to put it inside a variable called k so that I can breaking this out. Otherwise you can also you can also write it down in the same line. So let's say if equal to cb2 dot wait key, you can give it here 1 or 10. Okay, and also equal to ord of the queue. If anyone press the queue from his keyboard, it will automatically gone the frame. Let's making it black. Then after that we're simply going to release our video. So let's try to release it. So let's say video dot release, and also I am simply going to destroy all of the window. Let's say destroy all windows. Also one more thing, if this rate is not giving you the binary value should be the one, it will automatically close the frame. That's mean your video path having some problem. So in this kind of cases, so what I can do, we simply going to checking that. We can checking that if not red, then we're simply going to break in this out as well. I mean, if your path of your camera or the video is not valid, it will automatically break the law. So if I save it and try to run the code from here, and then you can see our image, I mean, sorry, our not image, actually our video should be running up here. Just why? Because it is loading here our deep learning model and as well as our position list. Okay. Now, what I can do now, we're simply going to also give here one thing. Let's first try to loading it out because it is taking time for loading these ones. And then what I can do, you can also creating here our parking plot and try to get the positions of each of the parking plot, right? I think it's opened or not. Yeah, it's open right now. Now you can see here this our video that you can see. But here's the problem that the frame is not correct. The frame is not available in our whole frame. That's when we need to also resizing these ones. Also, one more thing, how the video is ended, it will automatically closed. I mean, the video is nothing but the 40 seconds. So how the video is end, this frame is automatically closed. Automatically closed. So it also take care of them. It also take care of them. So let's try to first take care of them. So let's say if the cap, I mean cap is nothing but my video. If the video dot get equal to cb2 dot cap props, okay, props is nothing but prop, the positions, props of the positions is nothing but my frame, cap props positions, and we have the frame. Okay, you have the frames is equal to video dot get, and you have the cb2 dot cap underscore props. Okay, it's prop or props. It should be the prop, right? It should be the prop. prop position frame, and it is equal to prop of the positions dot count. I mean my frame count. So it should be our frame. You can see frames and underscore. You can see we have the count. See one thing, cb2 dot cap underscore prop underscore positions. Okay, it don't have any positions in the frame count, so you can remove this one. So you have the prop frames count. Again, see again, cb2 dot cap, okay, cap underscore prop, and then you have the frame count. You can see frame count. Same thing here, same thing here. You can see here, same thing here. So cap, see cap prop, then you have the positions, pause, and you have the frames. If it is equal to, then what I can do, we're simply going to set here our frame should be 0. So let's say cb2 dot cap and underscore props of the frame should be 0. That's when it will automatically looping this out, right? So now your video is not going to end here. Cool. Also one more thing, you need to also resizing the frame. So let's say what I can do, you can using here cb2 dot resize, and inside that we can passing here my image and as well as my size. So that's 120 and 720. Cool, right? Now we can simply go into working on that. So let's try to running this one, and also waiting for a few minutes because our machine learning model is also loading out here. Now what I can do, we simply going to checking the positions of the each of the car frame. I mean how the position is located, and also we are going to predict our data that if they have any car or not. That's mean we need to loading here our positions, current positions, right? So let's try to do that and try to checking here our frame methods. Now what I can do is simply going to creating here on variable, not variable, creating here a method. Let's say checking, let's say car parking, like that, and which one getting on image, and this car parking I need to implement this one. So let's say def car parking, which one taking one image, right? Cool. Now let's try to implement the car parking one. So what I can do, let's taking this one as the image. Okay. So first thing first, we're going to checking all of the position list from our position list. We're simply going to getting all of the position list from here and try to crop our images based on that, so that we can do the predictions, right? So what we have the X and Y in our positions, Then after that, we're simply going to crop the images in our frames. So what I can do, we can using here image that is coming from here, and we have Y to Y plus height, this height. So this height is nothing but coming from here. If I go inside my data collections, and you need to also initialize this weight and the height of that. So let's try to initialize this one. So it should be go from the Y to Y plus height, and X to X plus width. Cool now. So this is nothing but my cropped image, that how can you crop the images. So let's making this one, let's say cropped image, right? Now our cropped image is ready. Now we need to resizing this one. So let's say we can using here cb2 dot resize, and inside that I can passing here my cropped image, and also 48 cross 48, I mean the size that I need to passing inside my model. So this is called the image resize. So let's say image resize, resized. Cool. And after that, I need to also rescale them. So let's try to rescale them. That's image resize divided by 255. I mean the greatest pixel of that. And let's try to making it called image normalize. Cool. And after that, we're simply going to add all of our information inside a list. So let's try to creating a list of that. So let's making it, let's say image crops equal to just getting an empty list of that. So we can use in this one image crops and dot append, and you can put here all of my image normalize. So it should be image normalize. Now it's ready. So what I can do is simply going to convert this image crops into a numpy array. So let's try to convert them. Let's try to make it in numpy array. So let's say np.array, and inside that I can pass in here my image crops. And now we need to do the prediction. Let's say model.predict, and inside that I can pass in my image crops. So crops fit my predictions. Let's say predictions. Cool. Now I need to actually put these predictions inside my frame, as well as I need to create a rectangle for that. So what I can do is simply going to creating the rectangle, the same thing or same method that we actually do on here. If I go on here, and you can see here the same thing we can actually method we can actually using on here. The same way we can use it here, right? So you can copy this out. But before that, we need to also make it enumerate, so that I can get here the index of that. So let's say enumerate, and inside that we have all of our position list. Okay, enumerate. So thoda mistake ho gaya, enumerate. Cool. Now inside that we have our positions and also the index. So now let's taking it here. Let's say x and y is nothing but my positions, and then inside my positions I need to taking my argmax. So let's np.argmax of my predictions of the eye, because it having so many images, it should be cropped here in my curve. That's mean if I go inside my images, it will creating this one, crop these images, crop these images. So it will keeping one index number. Now based on the index number, what I can do is simply going to do the predictions, and that's why I'm going to using here np.argmax, and which one give me one integer ID. Then after that we can using the labels. Same thing we do on here in our Jupyter notebook as well. So we have the class dictionary, so class underscore dictionary, and inside that I can pass in here my int id, I mean my index number. So this is my label. So if the label is equal to no car, then what I can do, we simply go into giving one color. Let's say giving one color. So let's say 0, 255, 0. And then what I can do, we can giving here the thickness is equal to 5. And then we can also do the space counter. Let's say space counter is equal to nothing but plus equal to 0. So let's create one variable for that. Here I go, space counter equal to 0. And then otherwise we're simply going to copy this out, and I'm going to paste it here. And after that I need to change in the color. Okay, so let's give it here the BGR, she should be the red color. So let's say 255, that means nothing but the car as well. And a space counter it not be here because we need to just counting here the no car space in the car parking. Now we're simply going to creating the rectangle on that, right? So now what I can do, let's try to run it first, just checking that is working or not. Well, so now you can see here it is working, it detecting the frame, but the problem is it not showing the put text. So we need to also set here on put text. So let's try to put it out. So let's say cb2.putText, put text, and inside that I need to giving here first image, then I need to giving here my text. So text is coming from the levels, and then I need to giving here my origin. So it should be the x comma y plus height of that. So that's the height. Let's making it then in the bottom of that, and let's giving here the font face. So let's say cb2 dot font Hershey small or simple. So it's a font Hershey. Let's making it simplex. And after that, I need to giving here the font scale. Let's give it here 1, and color. Let's give it to the color. So let's give it here the color from here. Let's give it some manual color. Let's say 255, 255, 255. There's nothing but the white color. And thickness, let's give it here the same thickness. Here you go. Right? I mean this thickness, or you can also do it, give it manually. The thickness is coming from here just for this one. So thickness is nothing but for the rectangle. So you can give it manual. Let's give it here too. Okay. So now let's save it and try to test it out, and you also make it more beautiful. No problem on that. Wait. And let's try to checking this one. I also trying to making this one in the, from the application that you see in the first, right? I hope so it will showing up here. Yeah, you can see here it having no car, and all of them are the car. Cool. Now let's try to making it more cool. So let's try to do that. So let's close this one, and I am simply going to put here one code that I copied because it's up to you, right? So same thing, just I need to give in here one color. So for the no text color, it's nothing but the BGR should be green, so we can give in here a black color. So let's say 0, 0, 0, and otherwise we can give in here one white color. So let's say text color should be 255, 255, 255. Okay. So see one thing here, just we actually changing the font scale and also creating here a rectangle on that so that you can look better. Okay, you can see text size equal to cbt.get text size, and simply going to give it here the levels, and also all of the font scale is nothing but 0.5. Then we have all of the text X and text Y. Okay, same thing for the put text as well. Then inside that I can give it here all of the things. Okay, don't care about the code, you can get the code on here. It's just for make it cool, just like the CSS. So let's try to running this out and try to check that how it actually look like. Okay, then we're simply going to building here our applications in the Flask framework. Okay, just to avoid, because I'm going to using here the CPU, that's why these problems. And you can see no car, and also you can see all of the car here. Okay, You can also add here on put text so that you can also count here your space. Okay. But no problem. We're simply going to do this out in our applications. Okay. But we have 1, 2, 3, 4, and the 5. We have the 5 spaces. Okay. And here you can put here the cards. Okay. So you can also add here the put text so that you can also count the spaces. Okay. Just showing this out. Let's try to give it out. You can also give it out like this. But in this case, you need to give your own positions. So I don't know what are the positions here. So I need to give it here. So let's say cb2 dot put text, and inside that I can giving here first my images, and then I can giving here my space count. So let's say f string. Let's use f string. Let's say space count is equal to inside my space counter, because we already creating here one variable for that space counter. And then after that I can giving here the positions. Let's give it here, let's say 100. You can give it 115, and then I'm giving her colors. So font face, let's give it here cb2 dot font Hershey's simplex, and then I'm giving here one font scale. So let's give it here 1, and the color of the scalar, let's give it here the text color. This text color, and thickness, let's give it here 2. Okay. So now let's check this out, that is really working or not, and let's save it now. Because we already increasing here the space counter as well, so that's why we can give it out. Okay. Hope so it is loading fine. Yeah. Here you go. And you can see space counter is right now 3. It's 5. I think it is actually, to give it out the frame. So that's why this problem is happening. You need to give it out the frame. Otherwise it will give me some kind of errors. Okay, then what I can do, we can give it at the out of the frame. So you can give it here out of the frame, and then we can run in the seconds. Okay, this is the last time. And after that, I'm simply going to creating here our applications. Okay, so here you go. थोड़ा छोटा हो जा भाई, अब अच्छा लग रहा है. Fine. Now Flask is coming up here, and see that. Okay, cool. And you can see the space counter is item 5. 1, 2, 3, 4, 5. Cool. You can see space counter, but you give it to the black color. Okay. You can give it to the white color. It's up to you. Now what I can do is simply going to creating here our application. Now let's go on here. So now it's time to creating here our Flask application, so that we can see that how many spaces should be free and how many spaces should be occupied. And this is the code for that. And it should be the server file. And as well as we have one templates file. It's inside my template folder called index.html. So if I see my UI, this is my UI. It having one header called the parking space detections, and also it having 2 box, which one having the free space and also count of my free space, and as well as the occupied spaces, and all as well as the count of the occupied spaces. And also you can see here blank thing. Inside this blank thing, you need to put here your frame, right? And also you can see 2024 parking predictions powered by AI. Just giving here a footer on that. So this is the how the UI look like. Now let's go on the HTML file and try to check that how it is actually created. So if I go inside this index.html, we have one title that's called parking space detections, and as well as some styling based on my UI, right? But the main part is nothing but from starting from here. So which one having one parking space detections is nothing but my heading of that. Then we have 2 cart. We have 2 carts. So one cart is holding here our free spaces, and another cart is nothing but holding our occupied spaces. But here you can see one thing, that it having one ID inside my p tag. That's called free spaces and also the occupied spaces. And also by default it will filling with 0. By default it filling with 0. And also you can see here we having another class, another div, which one having our URL for video feed. So which will help us to show our video in our applications, right? Then we can giving here a class that's called image fluid rounded, and giving some style on that. Then after that I have my photo that's called 2024 parking space detections powered by AI. Then I also write here one JavaScript so that when the counter is coming from my server file, it will automatically show and automatically increase it, right? I mean, changing these ones. That's why I simply going to creating here an update method so that it can taking this one. And also you can see it's showing here what space count. This space count is also coming up from my main.py file. And if it is free spaces, because you already give here the ID for that, free spaces and the occupied spaces, then we simply going to give here the data which one is coming in the form of JSON from our main.py file. Cool. So don't worry on that. I will give you this index.html file as well as this full file also, right? So let's go on our server file right now. So we have the main.py. So first we importing in the Flask and also importing here the Flask and the random template, the response, and as well as the JSONify. So why JSONify? Because you need to also increase or decrease whatever the space in the real time. So that's why. Then you imported the CB2, also imported the BKL, then NumPy, then also load model, same thing. Then after that, we're creating here applications for that, load the model, class dictionary, then video capture objects in a cap, then the card positions as well as the height and the weight that we do in our test.py file. Same thing, just having some modification on that. Then after that, we're simply going to creating here one route. This is nothing but my initial route, which one is showing up here. Initial route, I mean this index.html. Then when the video feed is calling, it is showing it inside these sections. Inside these sections, this video feed. If I see this is video feed. I mean, it's been inside our card. I mean, this card, it is showing up our video feed. Okay. So which one is coming up from here? Then we're simply going to creating here a route for that. We're simply going to creating here first initial route, then also creating here a route for video feed, right? So it having one response and it will creating here a method called a generate frame. And after that, you're going to giving here one mimi type. Mimi type is nothing but the multi-type x mixed replace, and boundary is nothing but the frame. So you're also creating here this method called a generate frame. And if I go this once, you can see here we giving here while equal to true and also reading this frame. And if it is not success, then we're simply going to breaking this out and also resizing our frame and also going to counting here the checking the parking spaces. If you see that in the test.py file, same thing, the same code, just you're going to changing something. But here the problem, if you're trying to show your image, not image, video, you need to decode it and code it, and after that you need to decode it in a form of byte. So here you need to actually encode it in the form of the JPEG format, and you need to create a buffer for that in the byte format. Then you can give it here the same code technique and try to creating this generate frame. So this generate frame actually help us to creating the frame of that. Now our frame is created. Now we need to checking the parking system. I mean, how many spaces is actually occupied or free spaces. Okay. Then what I can do is simply going to calling this one. That's called a space counter. So how in space counter method is calling, it will first checking the frame, and then if it is success, then it will resizing the frame and checking these parking spaces. So what it can do, it can first check in the parking spaces, and this is the full method for the parking spaces that you created here. Same thing you created here. Then after that, see one thing, if I go down, just having one thing, just called total spaces is nothing but the length of my position list. So this is my position list. This is my position list. This is my position list. I just simply going to make it simple, because if I try to type it here, just like position list is quite bigger. So that's why I make it simple. Let's call it post list. And after that, I simply going to add one single line that's called total spaces, so that I can count that how many total spaces should be inside my frame. So my total space frame is nothing but my position list of by each of the parking spaces. Then what I can do, I simply going to return here the image, the space counter, the total spaces minus spaces counter. So which one is giving me the free, how many spaces is free right now, right? So space counter is nothing but the total space count. Space counter is nothing but the counting the spaces, because you already counted the space right now. And this is nothing but how many spaces should be there. How many spaces should be free there. Simple, just adding one line. If you go on the test.py, same thing, same code. Just add one single line on here, counting the total. So how can I do that? Length of the position list, right? Now it will give me the total spaces and the total counting space, free space, and the occupied space. So it's simply going to convert them into just unify. See, it give me the free spaces and the occupied spaces, and then I'm simply going to convert them into just unify so that we can pass it inside my HTML file. Inside my HTML file. So what I can do, I simply going to create the just unify, and by default I give it a 0 and the 0. Then how it will changes, the just unify is automatically changing the frame inside my index.html. Simple. If you want to know more about that, how can you create the frame in the Flux applications, or how can you detect the faces, you can also follow my face detections in Flux as well. You can also follow these ones. So here I'm discussing about everything. What is a mixed displays, what is a multiplot, what is a mimicry, all of the thing I actually discuss on here. Same thing. Okay. So now it's time to running this application. Let's try to running these ones. I hope you're having some problems because this PC I'm using, it's right now in the 4 year. So it will give me some kind of warning and some kind of actually problems in my PC. Okay. I think I need to buy one. But the problem is it's just a 25 subscriber. So it's better you make it increasing so that I can got some revenue as well. So what I can do, I'm simply going to go on this follow link. And now it will load in the applications on that. Just to wait for a few seconds because it's loading. And you can see by default is 0. And now it's changing 5 and the 51. Now you can see 1, 2, 3, 4, 5. It having the 5 spaces and the occupied spaces is nothing but 51. Right? So this is the full tutorial in the YouTube using deep learning. And I hope you enjoyed this full tutorial and subscribe to the channels and try to make me in the 100 subscriber and also share it with your friend. So that's it for today now, and I'll be back with the another tutorial. So till then, take care and bye bye.